All right, we are back with our second to last lab of the semester, if you can believe it. So this lab is, I think, a cool one because it pulls together a lot of what we've done for the last 2 weeks. So 2 weeks ago, we did unsupervised classification. And last week, we moved on from that and did supervised classification. And so, as you might imagine, with these classifications, there's some amount of error associated with them. And so, being able to quantify exactly how good, how accurate of a classification any given classification is really important. And so, that's what this lab is going to be focused on. We're going to be looking back at those classifications from the last 2 weeks and assessing just how good they are. And this is very common practice in remote sensing, and so I think it's something that a topic that's very useful for you to have some understanding of. There's a good chance if you're going into natural resources or cultural resources as a career that you'll be using at least some of the products that come out of these types of analyses. And so having some literacy of exactly what these values mean, these quantitative assessments of classifications, how to interpret them, is going to be useful to you, I think. So I hope you get a lot out of it, and here we go. So like I said, in this lab, we're going to be looking at the accuracy of the supervised and unsupervised classifications from the last 2 weeks. So the way we're going to do that is we're going to start off in step 1 by generating some random points. And then in the subsequent steps, we're going to look at the accuracy of each of those classifications relative to what they actually are in the imagery. So we'll get into that in the next few steps. But initially, we're going to start off by generating these points. So some of the early processing here will be familiar to you. We're going to basically just clip our image to those watersheds the same ways that we have for the last 2 labs. And so I'm not going to talk about that in any detail, but the next 2 steps will be new. So we're going to use what's called the dissolve tool, which is a very common tool in GIS. But basically, it's going to take our 3 watersheds and just dissolve the boundaries so that they're just one polygon comprising all 3 watersheds. So I think that'll be pretty clear once you see that. And then within that polygon, we're going to generate 25 random points, and that's what we're going to use for accuracy assessment. So I'll show you what that looks like. So initially, you're going to just have the watersheds. So I like to make them hollow, and then to have them outlined in some bold color. So you probably know this already, but you can always, to change that color, just click on the icon in the table of contents, and then you can change the fill color. So I have my fill color to none, and then the outline color to red, because that will be bold. So I've done that for all of my layers. So after running the dissolve tool, which there are instructions about how to do that. I think it'll be fairly straightforward, hopefully. Then that will leave you with this boundary. So it's just a polygon of the entire, 3 watersheds all combined. And so then at that point, you're going to use the random points tool to generate some points. So the best way to find that is going to be to use this search feature. That's my favorite way to do this anyways. And then you can just type in, I've already done it, obviously, already typed this in, but you can just search for it and then click it and then open that up. To get to the search you just want to go to Windows up at the top and then go to search and it'll open up. So that's how you'll get that. And then you'll just follow the instructions in the lab, but you'll end up with something that'll look like this. Your points will be in different places than mine, I think, because they're random points, so it should be random each time. So you'll end up with something like this. Again, I just changed the color and size to red and a little bit bigger so I could just see them more easily. And yeah, that's going to be it for step 1, and we'll move on to step 2. Step 2 is a really quick one. Basically, we're just going to be using this other common GIS tool called the buffer tool and applying a 30-meter buffer to each of our points that we created in the last step. And so they say the reason to use a 30-meter buffer is because the Landsat imagery pixels are 30 by 30. The kind of weird thing about this is that when you're using the buffer tool, it actually creates a 30-meter radius. And so we're actually creating, you'd have to calculate the area of a circle, but we're using a larger area than a pixel. So it's a little weird, but I think it's still useful because for all of us, it normalizes at least the area that we'll be looking at. And so we're just going to stick with that. And so what that's going to look like is you're going to run this tool called the buffer tool, which you can get to just by clicking geoprocessing and then going to buffer. And that'll bring up this toolbox, and the lab describes what to input. But I've already run that, so you can't see it at this scale. But if I zoom in on one of these points, and hopefully it will behave and not freak out, you can see that actually this point has this red buffer. And I've again made it hollow. And that'll be important because soon we'll be looking at the type of land cover underneath here. You can probably already see that it's very blurry and difficult to tell what's going on underneath here. So I'll talk about that here coming up soon as well. But for now, the only part of this step is to create this buffer. So yeah, that's it for step 2. I thought I'd give a little bit more detailed walkthrough for step 3. Steps 3 and 4 are a little bit more detailed and have a few more steps. And so I thought I'd kind of show what's going on. And yeah, so here we're actually going to be what's called ground truthing our points. And so basically, it comes from the term ground truth is usually you would do this for any sort of remote sensing analysis, but you would go out into the field and actually see what's going on the ground and make sure that matches with whatever classification or whatever type of value came out of your model. And so we are obviously not going to go into the field to Chesapeake Bay area. And so, and it's becoming more and more common in general now with high resolution imagery to just do this with the imagery. And so that's what we're going to do. And so to get set up, we're going to add a new column to our buffer. And so you'll just want to open up the attribute table, which I already have open here. And then you'll want to add a field. So it'll just be that, and then click add field. I've already added mine here. And then we're going to be turning on the base map of the satellite imagery. And so that's really going to help us to be able to see what's going on on the ground, because as we saw in the last step, the Landsat data can be really blurry, just because of the resolution of it. Sorry, wrong document there. So we've got that. And so once we're set up with that new column and everything, then we're going to go into this more detailed part of actually identifying what's going on the ground. So I'll show that in a sec. So at this point, we're actually going to go just point by point and make a determination about what the ground class is. So whether it's forest or whether it's developed or what have you. So we're going to have to start by turning on editing. And so you're going to want to open up the editor toolbar, which you can do by right-clicking the toolbars up here and turning on the editor. And then I'm going to click Start Editing. And you're going to want to select your layer. So mine's called Buff25. Yours probably is also. And this is fine. We can just click Continue. And so now we'll be able to actually edit these values in the GT column. So I like to dock my attribute table down at the bottom. So then I can, have my map clear up here. So let's see. The way that I would suggest doing this, first off, it's very possible that the base map could be slow and laggy. And so if that happens, what I would suggest is turning off the base map and then zooming to your point. And then once you're at your point, then turning back on the base map. So I'm doing this live, so we'll see how this works. But I think next I'm just going to go point by point and fill in the values for each of those points. So the easiest way to zoom in on each point is in the attribute table. You'll see these squares. Hopefully you can see them and my head's not in the way. But there are squares, these gray squares to the left of all of the attributes. And you can right click and on each of them and go zoom to. And here's where it might lag quite a bit. So not horrible, but now that I'm here, I can definitely, and I might zoom out a little bit too, because, just being so far zoomed in, you can lose some of the, whether it's forest or whether it's wetland. You kind of need to see the bigger picture. And so I might have said when it was zoomed in that it was forest, and I actually now see that it's very close to this stream here. And so I'm actually going to call this this wetland. And so that is class 5. And I'm just going to fill in class 5 like that. And then I'm going to right click on my next point the same way I did on that square and go zoom to. And it might lag a little bit. But you're just going to make determinations like this for each of them. So for this one, I'm probably going to call it developed. It's definitely a low intensity development. But there's housing. I mean, there are 3 houses in the buffer, so I have to call that developed. And so I'm going to call that 2. Oops, I typed an 8. We do not have 8 classes. And so you're just going to go point by point like that. And yeah, I hope that's fairly clear. The other thing that I'll mention about this is, they say in the lab to just kind of take the imagery as it is. A better way to do this is actually to check it against our imagery. So I'm going to turn on the layer again, and it's so blurry, it's really hard to tell. But as you might imagine, the challenge with this is that there can be a pretty big discrepancy in the date of our of our imagery, our Landsat image from 2006, and the base map's probably in the last year or two. And so, it's good to check it. It's so hard to tell what's going on in this Landsat image. And so, I think because there's still this like lighter, these lighter shades, I'm guessing this is still developed back then. But, just do kind of the best you can. But at least looking at that imagery is going to be important because that's what the classification was actually classifying, right? Not the base map. So if we're actually assessing the accuracy of the Landsat image, we should be actually looking at that Landsat image. So that's that. So as I'm going through this, I'm realizing just how heavily modified this landscape is. And so for a lot of pixels, it's not going to be super clear cut what the land cover is. And you're kind of going to have to decide. So for this one, you can see it's kind of like in the median of a roadway. And even on this left side, I guess the west side, the road enters into the buffer. What I would suggest is just going with what the predominant land cover type is in the pixel. So for this one, you can see I put pasture. It's not really forest, but it's some sort of natural vegetation. It looks like kind of a mix of shrubs and a few trees. So that would fit into that pasture class. So this is a very complicated landscape, and you're just going to have to make some tough calls like that. So that's what I've got. So I found a really good example of just how much these landscapes can change over the course of probably the 12 years of difference between the 2006 image and the base map. So I have this point. It's very clearly, I would definitely call this crop/pasture based on the satellite imagery. But if I turn on the Landsat image, you can see, look how much this landscape has changed. You can see that this field here has been probably agriculture this entire time, but you wouldn't be seeing, if this is this just doesn't look like agriculture. It's, a lot of differences in the brightness and greenness, and it just is forest. And so I'm actually going to call this point forest. So I just want to point that out. And I think that's, something really to keep in mind if you find yourself doing this in the future. And this, doing accuracy assessment is really common for this type of thing. So if you end up doing any sort of remote sensing or GIS as part of a future job, matching the date of the imagery you're using for ground truth to the date of the imagery that you used to create whatever classification or whatever is really important. And it's something that is a notable issue with this lab, partly just because of the age of this lab. So something to keep in mind. We're not going to do anything differently for this lab to fix that, but just in your own remote sensing literacy, keep that in mind. So I'm going to call this a forested class. So that's all. All right, so I just finished up my 25 points. So I'm just going to stop editing, and then we'll move on to step 4. Be sure to save your edits, by the way. Click yes to save your edits. Step 4 is pretty long, so I thought I might go over it in some detail. So essentially what we're going to do initially is to extract the values for each of the land cover data sets for all of our points, and then we're going to compare that to what we just ground truthed before. So you'll see that we're going to be using the unsupervised classification, the two supervised classifications that we had last week, and then a new classification data set called the National Land Cover Database. So National Land Cover Database, otherwise known as NLCD, is a really common, really popular, widely used, kind of the authoritative land cover data set for the US. And they've produced many iterations of it from the mid 90s until a new one just came out last year, updated to 2016 because it takes several years for them to compile it. And so we're going to be using each of those. And so I will show that right now. So you can see I already have all of mine in here. I have, int sup and unsup and max sup. So those are all in here already. And so you can see that I reset my symbology. If you have your symbology file, you can use that to reset it, but the names might be slightly different. Like I had mine called wetland, and this is called wetlands. And I think I had mine called like pasture/crop, and this is crop and pasture. So if you have that, it might not work well for you, but what you can always do is, I'll just do this like I'm adding. So you can see for this one, all the colors are not right. Well, you can import symbology from just one of the other layers in the map. So once you've set the symbology for one layer, you can just apply that for each of the layers. So yeah, obviously you could use your own layers for from the past two labs for assessing the accuracy. You can also, included with this lab is both the Land Cover 2006 from the National Land Cover Database layer, which you'll need because that's new. And then there are some other classifications in here. So that's what I'm using, and you're welcome to just use those if that's easier for you. And so the first thing we're going to do is to extract the points to extract the values from each land cover class for our points. And so there's a tool that I'm going to search for called extract values to points. And there it is. Notice this is using the Spatial Analyst toolbar. So if you're getting an error, the Spatial Analyst extension. So if you get an error, you're going to have to go up to Customize and then Extensions, and then turn on the Spatial Analyst toolbar. Notice that mine's already on. But we're going to do this for each of the sets of points. And so we'll do this. And first we're going to do LC 2006 rec. And then we'll rename, and I'm going to make sure that mine's going to my results folder. So there's results. Am I in the right? Am I in lab 9? Yes, lab 9. Okay. And then here, and it says to call it points 25.2, and I will save and click OK, and it'll run. And so that's the first part of this. We're next going to add an integer field and then calculate our land cover that way. But if we open up the attribute table here, you can see that now we have a attribute table that has the values of each of those points. So that's all for now. So that next step after what I just did, so running that tool created a new column called raster value, and we're just going to rename that column to LC, and that'll tell us that these values came from this layer here that my head might be in the way. No, it doesn't look like it is. LC 2006 rec. And so once we've done that, we can go ahead and delete this field. And then we're just going to do this same step for each of our layers. And eventually, because with each iteration, our new layer, that our input vector data that we're going to put in is going to be points underscore 25 underscore 2, and then points underscore 25 underscore 3. We're eventually going to have columns with all of the values of all of the land cover layers. So that's where we're going, and I'm going to go through those steps now. So I went ahead and finished the rest of my extractions for each of the layers. So you can see now I have a nice table. Yours might be in a slightly different order, but it should have each of these columns. You may have noticed, screwed up on my ground truth points before. I put them on the buffer layer, which I shouldn't have done. I'll be sure to include a text note at that point in the video. But anyways, I end up with a nice table here. You can see the classes that were extracted for each point. You can see that there's some discrepancy in some of these. The unsupervised classified this particular point as pasture when in fact everywhere else it is showing up as wetland. Also, the unsupervised classification water is really easy to distinguish across all of them. You can see I only had 2 water points, and they are all just, there's no disagreement there whatsoever. And just again to note that yours will look different than this because we use the random points. Your table is going to have different points in different locations, so all of the extractions will look different. But this is the idea, and this is what you want. And so next, what we're going to do is really kind of the meat of the lab, and that's where we're actually going to calculate the accuracy for each of these classifications. So as I mentioned earlier, this is incredibly important. For any sort of classification, you want to know how accurate it is. And there are a couple of different types of error that we're going to be assessing. And in the lab, they talk about these as creating an error matrix for omission and commission. If you've watched Dr. Levsky's video, often people will refer to these as confusion matrices or confusion matrices, which accurately describes them because it's very easy to confuse omission and commission. And I often have to look up the difference. And so the idea is that we're going to create a matrix that's assessing where value. So for a class that's been, so for a given point, let's say, if it's been classified as forest, but in fact it's wetland, that's one type of error. And then for a given point, if it's actually wetland, but it was classified as forest, that's a different type of error. So we want to know, be able to distinguish those types of errors to see how often the classifications are misclassifying going both ways. So I know that's kind of abstract right now, but I'm hoping that will make sense once we look at this confusion matrix. And so that will be the next video. So I think creating the omission and commission matrix can be a little bit actually pretty confusing. I don't think it's spelled out very well in the lab instructions, so I really encourage you to follow this video with creating them. We're going to create 4 different ones for each of the land cover classifications. And yeah, so I'm just going to go through this in some detail. So you'll see if you go into the Lab 9 accuracy assessment folder, yours might be named slightly differently. I might have renamed mine. But there's this Excel file. So go ahead and open that up. And you can click Enable Editing. And you'll see that there are 4 classification matrices in here. I went ahead and started filling out mine for water, and I'll explain that in a second. But the first thing I wanted to show you is how I would suggest organizing your screen to make this go more easily. So I would take ArcMap and just put it right here on the side, and then put the Excel sheet just right on the other side. And that way we're going to be able to work side by side with all of this. So we're not really going to need the map for this. We're really going to be working with our attribute table. So I've already opened up my attribute table, and I'm just going to make it, kind of fill this up just so, I don't know. There's already a lot going on my screen, so it'll help me keep it straight. And the bulk of our work is going to be using this select by attributes box. So you can see in the lab that there are some instructions about how to use this. So, it suggests how to open up the select by attributes. And then we're going to use basically these queries to look at where the ground truth values agree and disagree with whatever land cover class we're interested in. And so what that's going to look like is I'm on, I thought I deleted these out. So I already did water, and that's because it's not very interesting, because it agrees pretty much everywhere, like I said in the previous video. The classifications are really good at picking out water. Our ground truth, it's just like, well, it's, that point's in water. So it's not terribly interesting. But developed is a much more interesting land cover class. So I thought we'd start with that. So we're going to build one of these queries. And it's really just as simple as right now I'm using, I'm looking at the land cover NLCD layer, which corresponds to this LC column. So I want values where LC equals 2. And then I can use this AND operator. And GT equals 2. And then I'll click apply. And it's going to highlight or select all of the points for which both the land cover and the ground truth agree. And so you can see there are 4 points. So how we're going to use that to fill out the matrix is this kind of diagonal through the middle of our matrix is points that agree. And so you can understand that kind of intuitively. Ground truth here, these top values are for ground truth, and these side columns or rows are for how the data were classified, how those points were classified in the land cover map. And so for this one, the ground truth is developed and the classified category is developed. So I'm going to put a 4 in there because we had 4 points where those agree, where it was classified as developed and the ground truth was in fact developed. And so I mentioned in the previous video that there can be a couple of different types of error. And so those are omission error and commission error. And so we'll start by looking at omission error, which is where the ground truth was developed, but the algorithm classified it as something else. So it's omitting what was truly developed and calling it something else. So that's why it's omission error. And so ground truth in this case will be 2. And we're going to use this less than and greater than sign in this just means not equal to. And so when I apply this, I can see there are now 2 points where there's omission error, where the ground truth is developed, but in fact, the land cover classification classified it as something else. And so for those, I'm going to want to look at what value the classification gave for that. So we have 2 points. Those 2 points, LC for one of them classified it as a 4, so crop and pasture, and for the other, the NLCD classified it as a 3, so forest. So I'm going to put a 1 in each of those because there was one value, one point where developed was omitted, and in place of it, the algorithm called it forest. And so at this point, I can fill in wetlands with a 0. And so now I'm going to want to go back and change this equals back to equals, because now we're going to be looking for commission errors. So those are going to be values, sorry, those are going to be points at which the algorithm said, okay, this is developed, but in fact, the ground truth was that it was something else. So exactly the opposite type of error. For developed, we want now the LC equals 2, but ground truth to be not equals 2. So less than and greater than means not equals to, and I'm going to apply that. And you can see I only have 1 point this time. And so for this one, you can see LC equals 2, developed, but the ground truth is actually 3. So I'm going to put a 1 in the forest, and we had no points at which the classification called it developed, but it was crop or pasture or wetlands. So I'm going to put 0s in both of those columns. And so at this point, we can say that we can fill in these totals rows and column for developed. So there are 6 total here and 5 total here. So now we can get the omission and commission percentages, which I'm going to show in a little bit. I'm going to focus on filling in the rest of this table first. So next I'm going to move on to 3. So I'm going to move on to forest. And I'm just going to do the same thing. So I'm going to look for points where the land cover is 3 and the ground truth is 3 and apply. And I have 5 points. So I'm going to enter a 5 in here. And then I'm going to look for points at which the ground truth is 3, but the land cover is not equal to 3. And I'm going to click apply. And there are 4 of those. So for that, I have, let's see. So 1 is the developed, which we've already counted. So you don't want to go back and add to these previous cells. So if you've already filled it in, that's already the value. You can see I have 1 point that the ground truth was 3 and the land cover was 2. But you can see that I now have 2 points at which the ground truth was 3 and the land cover was 4. And 1 point at which the ground truth was 3 and the NLCD value was 5. So I'm going to put 1 more point in there. And then I'm going to look for commission error. Oops. So I'm going to change this to this, and this to this. So now I'm looking for points at which the NLCD classified it as forest, but in fact it was not forest, it was something else. So I have two of those points, and one of them you can see we've already filled in, so that's this point here. And that's one that the NLCD said, well, this is forest, but in fact the ground truth was that it was developed. And then we do want to add this point, which the NLCD said was forest, 3, but in fact the ground truth was 4, crop and pasture. So I'm going to enter 1 here. And I'll do a 0 for wetlands because there were none of those points. And then I'll total this row. You can see there's 1 point here, 5 here, and 1 here. So 7. And you can see that there are 5, 2, 1, and 1. So 9 total points here. If you're savvy with Excel, you can, you probably know you can create some formulas, but I think the math here is simple enough that you may not need that. So hopefully you kind of get the idea here. I'll go through each of these tables. I don't think it'll take me too long to do that, and I hope you'll have a similar experience. And so we're going to do this for all of the tables. So I'm going to go ahead and do that, and I'll show you what we're going to do next. So I just finished my table here. Obviously, all the tables will be very similar, but just for each of the classifications. So one way that you can check that your addition was correct, and that I'll be checking these also, is you want your totals for each of the columns to equal 25 because we had 25 total points. So right here we're just summing the values for which the ground truth was each of these classes. So these points, because we had 25 ground truth points, these sums should add up to, or sorry, these counts should sum to 25. So 2 plus 6 equals 8, plus 9 equals 17, plus 7 equals 24, plus 1 equals 25. And same thing over here. 9 plus 7 equals 16, plus 5 equals 21, plus 2 equals 25. So we're good there. And then you can see there's this producer's accuracy and user's accuracy, otherwise known as errors of omission and errors of commission, respectively. So for this, we want to hone in on the cells for that are highlighted in orange, and those for the total. And so for this, we're just going to do simple division of the correctly classified cells in orange divided by the total. So we could probably create some sort of like fancy Excel formula, but I'm just going to do some simple division. So I'm going to divide 2 by 2, and that's going to equal 0. Or sorry, equal 1. 2 divided by 2 does not equal 0. And so yeah, I'm just dividing the number of points that were classified correctly by the total of number of points that were classified, or that were ground truth as water for 1 or for developed here. So here I'm just going to do equals 4 divided by 6, and here will be equals 5 divided by 9. Oops, divided by 9, and equals 6 divided by 7, and equals 1 divided by 1. And so then I'll do the same thing over here for errors of commission. So I'm going to do total number classified correctly divided by the total. So 2 divided by 2, and 4 divided by 5. Oh, that was a problem. If you ever accidentally do that, you can right click and go to Format Cells, and you'll see that it set it as a date. So you're just going to have to go up and change it to, actually you can go to number, and that should be fine. So now I'm going to do equals 2 divided by 2, and equals 4 divided by 5, and equals 5 divided by 7, and equals 6 divided by 9, and I think you get the idea, equals 1 divided by 1. So now we have for each of our classes the omission-commission error, and we can do get total error as well. So our total samples is easy. That'll be 25. And we're just going to sum the diagonals here. So 2 plus 4 equals 6, plus 5 equals 11, plus 6 equals 17, plus 1 equals 18. So the total is going to be 18 that were classified correctly. And so our overall accuracy will be equals 18 divided by 25. So 72% accuracy. And this is plenty to get a somewhat robust estimate of the accuracy for these different classifications. And so I've only done this for one so far, so I'm going to go down and do the last three. And yeah, then we'll compare which one was best and move on with our lives. All right, I wanted to show the results of the accuracy assessment that I did. So yeah, you'll be working through this and your results will be different. So if you have the same results, I'll be a little worried. But you can go and basically compare on a class-by-class basis the omission and commission rates, which you'll be asked to do in some of the questions specifically for the maximum likelihood classification. And then you can compare total overall accuracy as well. And so you'll do that for both the NLCD layer for the unsupervised classification, and then for the supervised classification. Now, I want to point out that I discovered an issue with the supervised classification layers that I just can't figure out how to get around. So it's just going to be a limitation of this lab, unfortunately. But the two layers were exactly the same. And so you're going to have exactly the same matrix for the interactive supervised classification as the maximum likelihood supervised classification. I went back and tried to recreate those from the data that I'd made. So I went back to lab 8 and was unable to load the signatures file because ArcGIS wasn't recognizing it, and it was going to be a long process to recreate that. And because of just my need to prioritize to help you guys to get through the labs, it's just not going to be possible for me to do that. But I think the purpose of this lab is really to compare or to look at accuracy assessment generally. So I think, at a high level, the purpose of this lab is to look at, because that's the purpose of the lab, is to look at and interpret accuracy of these different classifications. You should still very much be able to do that. And the conclusions that you can draw, while kind of limited by the fact that we don't have two different types of supervised classification, you can still draw the same types of conclusions. And so I think the exercise is still valid, and I apologize for the error. I wish there were some way around it that wasn't as cumbersome as it is. So yeah, at this point you will you'll be submitting your omission commission matrices. They're a big portion of the lab grade, so be sure and get those in. And then you'll have 6 questions trying to get you to interpret these different rates. So yeah, go back and watch the section of that I had about omission and commission error, and make sure that you really understand the difference between those two types of error because you're going to be asked specifically about them here. So yeah, I think that pretty much covers it. And yeah, I know this the confusion matrices or omission commission matrices can be really confusing. So go back, rewatch that section of the video. I hope it's fairly clear. And yeah, good luck. Finally, don't forget to practice good data management. Make sure you know where your data is. And if you need a refresher, be sure and watch the YouTube video on data management for NR 323.